Assalamualaikum. We are going to continue with emission or effluent charge. This is another form of pollution charge. What is emission or effluent charge? Emission or effluent charge refers to a fee imposed directly on the discharge of pollution. So we impose fee. So in other words, we assign price to pollution. It means a polluter can pollute, but they will have to pay for the pollution. So if it is air pollution, the charge is called emission charge. For water pollution, the charge is called effluent charge. Usually the charge is based on quantity or volume of the pollution. It is typically implemented through a tax. Okay, let's assume we have two models. We have two models to be analyzed, either single polluter model or multiple polluter model. We start with a single polluter model. For a region, there is only one polluter. We normally will combine a market approach, such as this charge, emission charge, with a CAC method. And it means that we combine our market approach with environmental standard. So assume that the government has set an abatement standard level at AST, and the options for polluters is either they abate or they pay tax. If they don't abate at all, they have to pay tax for the whole of their production process up to AST level. Okay, so here we have marginal abatement cost that somehow intersect with the tax function, the marginal tax function. So what we can see here is firm actually will pay tax, will abate from 0 to A0. This is the amount of pollutants that the firm itself will abate, maybe through adding scrubber system or a filter system, or using a process that allows them to reduce their pollution level. Up to A0, firm will abate, and above that, up to the standard, firm will pay tax. Okay, firm will choose the least cost option for the total amount of abatement from 0 to AST. Okay, the same model if described again. So we have marginal abatement cost, marginal tax function. For the firm, it needs to abate up to AST, the standard that is required for the firm, and the firm is the only firm around. So firm will abate up to A0 since marginal abatement cost is less than marginal tax, and after that the firm will pay tax until maximum AST. So this purple area here represents the total abatement cost for the firm, while the white area here is the total tax collected by the government due to the firm paying tax for not abating. From AO to AST is where the firm does not abate. Okay, for this model that we did just now, the advantage of this model, what are the advantages of this model? The advantage is the government is able to implement the regulations successfully because firm will meet the standard, right? And the firm actually meets the standard not by paying tax, but they abate some amount, and after that certain amount they pay tax. So another advantage is there is a collection of revenue for government to do clean up for the remaining amount here that the firm does not abate. In the long run, if this firm is able to reduce its marginal abatement cost and rotate it downwards, so that it reaches B point here instead of A, so the firm would be able to further increase their marginal abatement cost to a higher amount of abatement level, and they can avoid paying tax altogether if they can do so. So these are the advantages of emission charge. And emission charge is better than product charge in a way because it does not relate to output products. For product charge, you have to reduce it will lead to reduction in output, but for emission charge, it is directly on pollution itself, so it does not affect the output. Okay, let's model the multiple polluter case. So we are assuming two polluting sources, two firms in the same region. Each can generate 10 units of pollution, or in their production process, they tend to generate 10 units of pollution. But so for two firms, there will be 20 units of pollution generated. Let's say government set limit for pollution to only be 10 units. So AST is 10. And in order to achieve that, the government imposes emission charge of $5 per unit of pollution. Okay, next, because we have two polluter, we can combine the two MACs in one same diagram. One will be shown on the left, one will be shown on the right on the vertical axis. Okay, so on the horizontal line, we shall be reading in two ways, one from left to right, another from right to left, depending on which firm you are talking about. So polluter 1, assume that you are given TAC 1.25A square. You can get marginal abatement cost by doing the derivative of TAC with respect to abatement level. So it is 1.25 times 2 becomes 2.5A. So the power here becomes 1. Alright, and for polluter 2, assume that for polluter 2, TAC is somewhat lower. So you can see here MAC is lower because the total abatement cost is also lower. MAC is 0.625A. Right. The solution for this two polluter model is such that we say that the best way to solve the problem here is to abate up to the point where MAC equals MT. So where does the solution come from? This comes from the incentive of the polluter itself. Okay, government simply say that 10 units of pollution needs to be abated. So who will abate? Is it for firm 1 or firm 2? Based on our analysis just now, firm 1 has got higher marginal abatement cost. Firm 2 has lower marginal abatement cost. So let's look at each polluter's capability. For polluter 1, it will abate until the point of MAC of that firm is equal to marginal tax. MAC equals marginal tax, you just take firm 1's MAC function equals per unit tax, you solve it, A is 2. So firm 1 is actually a high cost abater and it only is willing to abate up to 2 points. For polluter 2, the marginal abatement cost when equated with marginal tax, you get the result 8. So polluter 2 is actually a low-cost polluter, and due to that, when you equate MAC with marginal tax, in the end, we find that polluter 2 prefers to actually abate more than polluter 1 because it has lower marginal abatement cost function. And if the whole thing here, total is 10, so the 10 units will be somehow divided between polluter 1 and polluter 2 based on their abatement cost. Okay. So, if we look back at polluter 1 only abate 2 units. And if you look at TAC1, you insert the 2 units, the total cost of abatement is 5, while the total tax paid by polluter 1 is 5 ringgit or $5 times 8 unit. Because the firm only abate 2 units, so the remaining 8 unit, the firm will simply pay tax for the 8 unit of pollution incurred. So it is 40 total amount of tax paid. For polluter 2 abates more, 8 units. Abatement cost is the total abatement cost function. You put in the 8 value, you got 2. and the total tax paid, because the polluter to pay only 2 units times the tax unit, so it is 10. So here it indicates that polluter 1 abate less and pay tax more because it is a high cost abater. Polluter 2 abate more and pay tax less because it is a low cost abater. In terms of diagram, we reflect the same diagram as before. Let's say that the government is able to identify the amount where MACs are equal. This is again a difficult thing to do, but in theory, assume that the government is able to identify MT to be 5, and this marginal tax of 5 ringgit is just right for the whole region here, because it allows the pollution level to be distributed among the two polluters in a way that their marginal abatement costs are equal. So total abatement level is 10, and TAC1 plus TAC2 from our previous analysis is now TAC1 plus TAC2 equals 25, and total tax payment is 40 times plus 10 is 50. Okay, so here this area here, the lined area here, reflects total abatement cost of firm 2, and this bigger triangle, right triangle here, is total abatement cost of firm 1. Together it becomes 25, and this whole purple area rectangle here is total payment of total tax payment of which firm here, of firm 1, and this blue rectangle here is total tax payment of firm 2. Okay, so the whole total area is 50. Okay, so for the model, we can conclude that it is cost effective because MACs are equal, and government is also able to collect tax revenue from both firms. And for the firm, it's good because the low cost abater tend to abate more, the high cost abater tend to abate less and pay tax, and the government's aim to reach the abatement standard of 10 units is met. However, in terms of the disadvantage of the model, again, it's very difficult to determine how much tax to allocate for that industry. They need to know the marginal abatement cost. Where is the marginal abatement cost equal? Normally, the tax will have to be adjusted until the objective is achieved. Okay. Also, the disadvantage is monitoring costs will be very high because they will have to monitor the two firms, and they will have to see whether they have abated certain amount, and to ensure that the balance they have to pay tax. So monitoring cost is there, and sometimes firms will try to evade tax by illegally disposing the pollutants. And another disadvantage is consumer might have to pay high price due to the tax, and job losses may also result from polluter paying new tax or changing technology to abate. Okay, so these are some of the disadvantage of using emission or effluent charge. In practice, are pollution charges being used? Yes, a lot of countries actually use pollution charge for water pollution, for air pollution, for certain kind of waste generated by industries. Normally, pollution charge is for industries because they can directly go to specific industries. Okay, for some countries, there are those that use effluent charge to control noise pollution generated by aircraft. Okay, and another example here, we have London City imposing T-charge. T-charge is toxicity charge in certain zones on the usage of old cars. So here you can see here in London, in certain areas, central zone here, they have a zone called ultra low emission. So in that zone, certain cars will have to be taxed if they go through this area to ensure that the zone is a low emission zone, low emission area, and they want to maintain high quality of the air. So these are some example of pollution charges. There is some more example here. Water pollution charge in the Netherlands. Okay, the charge is implemented by water boards or self-governing bodies of surface water responsible for water management. It's based on effluents. The effluent here is biochemical oxygen demand and heavy metal pollution. It is levied on all direct and indirect discharges. So this one is for household and small firms. They pay a fixed amount. Okay, so here is actually a page, an excerpt from a report by World Bank. So actually for this water pollution charge in the Netherlands, is it good or not? It is said here that the level of charge is rather high and aimed at providing full cost recovery of sewage treatment. It is transparent, so actually this is good. Okay, directly linked to pollution load for large firms. Another one is sulfur tax in Sweden. It is levied on sulfur content of diesel fuel and heating oil that exceed 0.1%. The tax here, by the way, the tax here is a product charge rather than emission charge. Approximates an emission charge. It is a product charge which somehow replaces an emission charge. Is repayable is if a taxpayer can demonstrate an actual reduction of emission of sulfur oxides. Okay. Does it work? The tax level is high, so it works. Okay. A high tax level can usually control emission because it discourages you to emit, because you have to pay for tax. A transparent rebate scheme, low administrative cost, the burden of proving actual emission is imposed on polluters. The burden is imposed on polluters. Okay, so actually this is for the polluters, but it is implemented on product, on the diesel itself. But it is said that repayable if taxpayer can demonstrate actual reduction of emission of sulfur oxide, so returnable. Okay, so these are some examples.